Good afternoon to everyone. So today we are going to take up this nomenclature of organic compounds. Okay. Aliphatic is C2H4. Absolutely right. Absolutely right. So we are going to start our session now. So our main organic compounds. I want to know from you what you can respond your chat box in the chat box. The calcium oxide is what? It is organic or inorganic? Calcium oxide is organic or inorganic? This is the question to you. Calcium oxide is inorganic. Fine, that's okay, that's done. Now I am making it small so that we can understand easily. So now I want to know from you ethyne. Ethyne is organic or inorganic? Tell me. Ethyne is organic or inorganic? Yeah, it's organic. So I am moving here. So it's now this is also done. So now I want to know what about CO2. What is CO2 is? Whether it's organic or inorganic. CO2. Please tell. CO2 is inorganic. Absolutely right. Absolutely right. Compounds of carbon and oxygen, they are inorganic. Okay, please keep in mind. Now, if I want to ask you that what about ethanoic acid? What about ethanoic acid? Whether it's organic or inorganic? Ethanoic acid. It's organic. Yeah, absolutely right. So if I want to say that methane, CH4 is organic or inorganic? Can anyone tell please? CH4 is organic. Let us say organic here, right? So now if you talk of ethene and ethane, these two hydrocarbons, I want your response that whether it's organic or inorganic. Ethene and ethane, these are organic or inorganic? Please write in the chat box so that we can come to know that how much you know. Yes, organic. Yes, absolutely right. These are all organic compounds. And left here is 2. Sodium chloride. Please write what is sodium chloride, whether it's organic or inorganic. Sodium chloride. Sodium chloride is inorganic. Yes. And what about sulfuric acid? What about sulfuric acid? Sulfuric acid as well as inorganic. So now the basic area is very much clear to us that organic and inorganic compounds. Organic compounds carbon. Organic compounds contain hydrogen. Organic compound contains oxygen. Is it right? 3 things. Carbon, hydrogen, oxygen. As well as it can be nitrogen, it can be sulfur also. Can you write any name? Can you write any name where we can say nitrogen is there? Where nitrogen is there in the hydrocarbon. Can anyone write any name? Where nitrogen is also there. Yes. Can, please. I'm waiting for your response in the chat box. If you can write any organic compounds containing nitrogen. If you write any organic compound containing nitrogen. Any organic compound containing nitrogen. I will just give you the hint. It would be amines. Amines. You have to write the hydrocarbon. CHN. It's no SH, no name SSCH, no, and it's not this feasible organic compound. Any other than that. Any other than that. If you write methane, let us see if you write methane, CH4, and remove H. Oximes, yes. Oximes, yes. Oximes, yes. But you will find difficulty in completing that, and no H bond is there in that. So now I want to make it very simple. You are having CH4. CH4 is there with you. CH4, remove one H. Remove one H and place NH2. What will be the organic compound? If your CH4 is there, remove H and place NH2. What will be the hydrocarbon? CH4, remove H, add NH2. Add NH2. Yes. What would be the answer? It would be CH3NH2. Yes, CH3NH2. These hydrocarbon known as amines. So what we conclude from here? Hydrocarbons are not only carbon and hydrogen. Hydrocarbons are carbon, hydrogen as well as nitrogen can be there, as well as oxygen can be there, as well as sulfur can be there. So it's not only carbon and hydrogen only, but it can be oxygen, it can be nitrogen as well as sulfur. This is clear to you? This idea is clear to you? Yes or no? Please. Hydrocarbons. Hydrocarbons are compounds of carbon, hydrogen as well as oxygen, nitrogen, sulfur also there. Right? Let us move ahead. If you talk of homologous series, if I am not going into the detail of the theory in this aspect, homologous series is having same functional group. Functional group, or we can say they are the series where the first member and the second member differs by CH2. Let us take the example. First member of alkane family. Can you please, anyone can speak? First member of alkane family. What would be? Alkane family, what is the first member? You can speak methane. Yeah. Second member is ethane. Right. So now if you find the formula difference in the formula. For example, methane formula is CH4. Ethane formula is C2H6. If you differ means C2H6 minus CH4, you will get CH2. So it means that hydrocarbon, the difference between the successive member is CH2. What is this? Is the characteristic of homologous series. The characteristic of homologous series is first member and second member differ by CH2, and the mass of, as just Skirata already written, that mass would be 14. 12 plus 2, 14. So the first member and second member, if you calculate the molecular mass of methane, if you calculate the molecular mass of ethane, the difference will be 14U. 14U means 14 atomic mass units. Is it okay? If this characteristic is clear to you, that first member and the second member differ by CH2. This is clear to you? Homologous series. Yes. Okay. So now, first of all, we talk about the basic homologous series. Basic homologous series it is there on your screen as such. It is alkane, alkene, alkyne. You know the formula for that. I am not going to repeat all these things. You know the formula CnH2n plus 2, CnH2n, CnH2n minus 2. These are the general formulas. Okay. So now, if you remove one H, let us take the first hydrocarbon. First hydrocarbon of alkane family is methane. Is it right? First hydrocarbon of alkane family is methane, CH4. So if you remove one H, what it will become? Please write in the chat box. If you remove one H from methane, what it will become? It becomes CH3, and that is known as methyl. Okay, so now if you say I am having alkane general formula is CnH2n plus 2, right? This is you know. So if I am removing one H, what will be the formula? What will be the formula? Please write. Please tell me. What you can write in the chat box. I will write here. So we will match whether we are matching or not. Please see. Is this the formula which you are getting? Is this the formula what you are getting? Yes or no? CnH2n, not just this is not 2n minus 1, it's 2n plus 1. Yeah. So CnH2n plus 1. So it means this CnH2n plus 1 is known as alkyl. This is known as what? It's known as alkyl. Got it? So this is known as alkyl, and it is also known as R. Alkyl or R. Right? This is clear to you, both of all of you? This is clear. R is alkyl and general formula is R. Is it okay? And R represents CnH2n plus 1. Is it okay? Yes or no? Yes. So now you have removed H. Now I am saying to you is you change H with, what do? You change H with OH, means R you can take, what you have to do is, just 1 minute, R you have to take plus OH. What will be the formula then? What will be the formula? ROH. Is it ROH? Right. So now the new functional group come into existence, that is known as alcohol. So it means all other hydrocarbons are obtained from the basic hydrocarbons that are known as alkane, alkene and alkyne. So basic is alkane. From that alkane you can make alkene also. Then from alkene you can make alkyne also. But basic is alkane. From alkane we are deriving alcohol, aldehyde, carboxylic acid, ethers. All the functional groups are derived from hydrocarbons, main hydrocarbons that are alkenes. So everyone is clear about these root carbons. Everyone is clear about the root carbons, so that I need not waste time and move forward. C1 is meth, C2 is eth, C3 is prop. Akshita, beta, you have to see this session will go up to 45 minutes. Okay. So number of carbon atoms are C1 is carbon, C1. Number 2 ethane. Number 3 propane. C4 but. C5 pent. C6 hex, hep, oct, non-dec. if this is clear to you, we can move forward. We need not to waste time over here. So please type, if you are clear about the root carbons, means C1 says what, C5 says what, C7 says what. If you are knowing that, we can move ahead. Please write if you are okay with that, so we can move ahead. Please. Okay, fine. So let us continue with the next part. So we are having, just see, if we have written this, let us say, these are our hydrocarbons. As I told you, if I am having R, I am attaching Cl. What would be the name? What would be the name here? Alkyl chloride. Is it right? You are clear with this? What I have written? Please see. Tell me. This is clear to you? R means CnH2n plus 1. And if you attach Cl, what will it become? Alkyl halide. Yes. So now I am changing this method. Now what I am doing is I am changing RCl with ROH. ROH. Can you write in the chat box what would be the hydrocarbons? What would be the hydrocarbons? Can you write in the chat box? Please tell. What will be the hydrocarbons? It is flashed on your screen as well. It is ROH. And that is alcohol. Right? Alcohol. Alcohol is the functional group. That further name and all that we will take up. Right? Now, what I am going to do is, I am changing into CHO. Can you write the name of this hydrocarbon? What would be? RCHO. What would be the hydrocarbon for this? What is the functional group? What is the functional group which contains RCHO? Can anyone write please? RCHO. You know alkyl halide? Sorry, R is alkyl. CHO. What is the functional group? What functional group CHO represents? Aldehydes. Yes, aldehyde. So let us move ahead. If you change CHO with COOH, if you change with COOH, what do you say? Now what do you say? What would be what is the functional group here? What is the functional group here? RCOOH. What is the functional group here? So until and unless carboxylic acid. Carboxylic acid is the functional group. Now if I will change this into ROR, can you please tell me what is the functional group now? What is the functional group now? Whether it's alcohol, whether it's carboxylic acid, whether it's aldehyde, yes, answer came here is ether. So ether. So first and the foremost thing is we should know the identification of the functional group. So whether we are knowing the functional group, then only we can do the naming. So this is the prime importance. Now one question, last question to you is, please you have to tell me which functional group it is. Please tell. Which functional group it is? Which functional group it is? Please tell. No, ketone, it's not ketone. It's not ketone. It's not ketone. It is the derivative of acids. It's the derivative of acids. No. It's not carboxyl. No. It's not carboxyl. It's not alcohol. It's not ether. What would be? It is the derivatives of acids. This is ester. This is esters. Yes, it's ester, Gidali. Right. So esters. Ester, you know, you have used it in the preparation of alkanes also. Okay. So now I am moving ahead. Now you are pretty clear about these fundamentals. So now I will go a little bit in the detail. So here, haloalkanes. Haloalkanes nothing but RX. Haloalkanes nothing but RX. Where X is halogen. Okay. Similarly, alcohols. Alcohol is nothing but ROH. And aldehyde means RCOH. This is the general formula I am talking of. Ketone. Ketone we have not discussed here. Let us discuss also. So this compound is ketone. This compound is ketone. Is it clear to everyone? Ketone. This compound is ketone. Right? ROR is ether and RCOR is ketone. We will write in the structure formula. You will be more clear with that. Okay. So now let us move ahead. Carboxylic acid, you know. RCOH. Now here in this you are finding one point. See please. Here these are the compounds. This is prefix. This is example and structure. Let us see. Haloalkanes prefix. What is prefix? Like halo. Halo is prefix. Halo prefix means chloro, bromo, iodo. These are prefix. Right. So when you write about the name of these compounds like alkyl halide, you are not writing propyl chloride. This is wrong. It's not IUPAC. It is common name. If you write propyl chloride, it is common name. It's not IUPAC. So you have to speak first prefix, that is chloro, and then root carbon, that is propane. Please remember that. Okay. Similarly, if you are talking of alcohol, first you will speak about root carbon, that is how many carbon it has. It is having propane, 3 carbon, plus what will be there? That will be suffix, and suffix for alcohol is ON. So this is known as propanol. Similarly, if you talk of aldehydes, if you are having 3 carbon, propanol, fine. Similarly, if you are having ketone and if you are having 3 carbon total, propane plus ONE, that is propanol, right? So more detail we will take up. First, we are doing about the general functional group and the name. Okay. So similarly, if you are talking of carboxylic acid and this carboxylic acid is having 3 carbon, so it will be propane plus suffix. What is suffix here? Oic acid. Propane plus oic acid, that is known as propanoic acid. So please remember that 2 vowels cannot come together. Therefore, propane, E and O, both are vowels. They cannot come together. So E has been eliminated. So please remember this thing. Similarly, propanol, E was there and O was there, E is removed. Similarly here, propane plus L, E and A, both are vowel. So E has been removed. Similarly here, propane plus ol, E is removed here. So this is the main fundamentals in the nomenclature. We will move to the, if this part is clear to you, so we can move ahead. Please type yes or no so that we can move ahead. If any doubt is there, you can ask us. Yes, I am waiting for your response so that we can move. Okay, fine. Ester is a derivative of acid. EC. This is acid, right? This is acid. Okay, this is acid. So what we are going to do is we are minus H. If minus H is there, it becomes RCOO and negative. Okay, so when you add one more R, it becomes what? RCOO. This is the way how we should know all these things, right? So please see. Have you got it? This way. Okay, so this is ester. When you talk of, I can give you one example also. For example, we have written the name of, let us say, methane, decarboxylation reaction, you remember. Yeah, CH3, COO, Na plus NaOH give rise to CH4 plus Na2, CO3. This reaction is not done. Yes or no? So this reaction is nothing but it is ester based. It is like sodium ethanoate. So when we talk of ate, that is ester. Okay, got it. So now we are moving ahead. So because ester as such, the nomenclature will not be asked. So let us move ahead. You have to tell me which is the functional group. Please tell A, what is the functional group. I am talking of A. Which functional group it contains? Please tell. A, which is the functional group in A? Yeah, absolutely right. Alcohols. Now let us move to B part. Which functional group it contains? Which functional group it contains? B. Which functional group it contains? It contains ketone. Absolutely right. Third, which functional group it contains? Which functional group it contains? Carboxylic acid. It means carboxylic acid is a combination of ketone as well as alcohols. Is it right? Carboxylic acid is a combination of ketone plus alcohols. Right? So this is what we need to know. Now you have to tell me which functional group, which hydrocarbon it is. Okay. So I will ask one by one. So you have to tell me first this CnH2n plus 1. Please tell which hydrocarbon it is. It is which functional group? No. This period it's not alkyne. It's not alkyne. It's alkene. I'm talking of CnH2n. Okay. Similarly, 2 CnH2n were there. So both are alkene. Okay. Both are alkene. Now come to this compound. This one. Blue. What would be this? Big one. Blue. RCOOH. What is this functional group? Carboxylic acid. Yes. What about this ROR? ROR. What about ROR? What function group it is there? ROR. Ether. Yes. What about CnH2n plus minus 2? CnH2n minus 2. Whether it's aliphatic, aromatic, aliphatic is there. Alkyne. This is alkyne. Okay. What about RX? What about RX? RX. What about that? It's alkyl halide. Yes. It's alkyl halide. What about ROH? If you talk of ROH, what would be that? ROH. ROH. It is alcohol. What about aldehyde? Oh, sorry. Okay, what about RCH? It's aldehyde. Okay. What about ROR? Last. ROR. What would be this? ROR. It's ether. So now you are clear about the function group. Let us move ahead. So now we have understood that hydrocarbons can be alkane, hydrocarbon can be alkene, hydrocarbon can be alkyne. Okay. So next thing is, hydrocarbon can be alkane, alkene, alkyne. And alkane characteristic is what? Single bond. Carbon-carbon single bond. At least one. Okay. Alkene, carbon-carbon double bond. At least one. So other can be single bond. Alkyne, one carbon triple bond. Carbon-carbon triple bond, one minimum required. Other can be single. So fine. So this is about hydrocarbon, alkane, alkyne. Formula you know. Alcohols. Alcohols ROH. ROH. Aldehyde RCHO. Ketone ROR. RCOR. RCOR. And carboxylic acid RCOOH. Similarly, ether ROR. Alkyl halide RX. So I feel these functional groups are clear to you. Please type yes. These functional groups are clear. So we can move ahead. Okay. Let us go with the naming. So you know, So you know hydrocarbons are of two types, saturated and unsaturated. And saturated hydrocarbon contains carbon-carbon single bond, double single bond, and unsaturated contains carbon-carbon double bond.
Nomenclature of carbon compounds. The names of compounds in a homologous series are based on the name of the basic carbon chain modified by a prefix phrase before or suffix phrase after indicating the nature of the functional group. Naming a carbon compound can be done by rules. 1. Identify the number of carbon atoms in the compound. If 3 carbons are in compound, give name propane. 2. If any functional group is present, it is indicated in the name of compound with either a prefix or a suffix. 3. If the name of the functional group ketone is to be given a suffix, the name of the carbon chain is modified by deleting the final E and adding the suffix ONE, propanone. 4. If the carbon chain is unsaturated, then the final ANE in the name of the carbon chain is substituted by ENE, propene or YNE, propine.
Please start.
Example, I take methanol.
Okay.
Like CH3OH, root carbon is the meth.
Okay.
And AN is for single bond, and OL is for it is alcohol.
Okay. Fine. So that's right. So what you want to say is, if you have taken methanol as the hydrocarbon, CH3OH is the formula, root carbon is 3. That's okay. And you have understood that suffix. Suffix is "ane" as well as "ol." So there are two suffix. One is "ane", that's primary, and then next is "ol", that is secondary. So two suffix are there and no prefix in this methanol. So can anyone tell me any other example where prefix is also there, where root carbons are also there, where suffix is also? Can anyone tell the name of the organic compound where prefix is also there, suffix is also there, and the, tell me, prefix, suffix and root carbon, 3 things are there. Any name of the hydrocarbon? Can anyone please tell? What will be the name which contains all the 3? Prefix, suffix as well as
Chloromethane.
chloromethane. Okay. So here chloro is there. Chloro is prefix, right? Absolutely right. And we are having meth. Meth is root carbon, and ane it is suffix, right? Absolutely right. So any other hydrocarbon, for example, if I will say you 2-methyl, 1 iodoethane is also right. 2-methyl propane 1-ol. Can you please tell what is the prefix? 2-methyl propane, 2-methyl propane 1-ol. 2-methyl propane 1-ol. Please tell what it contains. 2-methyl propane 1-ol. What would be? Which is prefix, which is suffix, which is root carbon, which is primary suffix and secondary? Can anyone tell? 2-methyl propane 1-ol. This is the question. 2-methyl propane 1-ol. You have to tell which is primary, prefix, suffix, all these things you have to tell. Anyone? 2-methyl. 2-methyl is what? 2-methyl is prefix, okay. Root carbon is prop, fine, absolutely right. Ane is primary suffix and ol is secondary. Absolutely right. Yes, Gitali, you are right. So these are the, if you understood this, so naming becomes easy for us. Now homologous series, I will not spend much time. You are aware that methane, ethane, propane, butane. So each successive member, first and second member differ by CH2. Okay. Similarly, alkene also the same case, alkyne also the same case. And the difference of the molecular mass will be 2. Now one more question I want to ask you from homologous series. Homologous series, which properties remain same and which properties changes? In homologous series, which properties remain same and which properties changes? This is also one of the characteristics. In homologous series, some properties remain same, some properties change. Which are remaining same and which are changing? Please tell. I'm waiting for your response in the chat box. Which properties remain same and which properties are changing? Chemical properties remain same. Yes, absolutely right. Physical properties changing. So you know that like methane is a gas, and if you talk of decane, it will be liquid. Got it? So this way, the properties, physical properties are changing. Chemical properties remain same. Now alcohols also the same case. If you take first member and second member, what is the difference? Please check and tell me. What is the difference between the first and second member in case of methanol and ethanol? Methanol and ethanol. What is the formula difference? Formula difference between the methanol and ethanol. Calculate. It is CH2, and CH2 is equivalent to 14U. 14U means 14 atomic mass units. The difference is there. Okay. So this will be a common characteristic. Whether you take aldehyde, whether you take carboxylic acid, whether you take alkylide, alcohol. So first and the second member differ by CH2 always. Right. Now, as I was telling you, nomenclature based on 3 things: root carbon, suffix and prefix. So root carbon, so you are clear that C1, C2, C3, C4, C5. C1 meth, eth, prop, both, pent, hex, oct, non, dec. These are root carbons. Suffix is what is at the end which is there. Ane, ene, ine. And if ane, these are primary, and if you change it into alcohol, so this becomes secondary suffix. Okay. So similarly, if it is a prefix means, as you know that sometimes you remove H and place Cl. Sometimes you remove H and place CH3. Sometimes you remove H and place C2H5. So those things which we are getting after removing of H, that are known as prefixes. Okay, so you will come to know more when you apply that. Okay, let us see. So now I am just moving forward to the nomenclature rules. The first and the foremost rule is longest chain rule. So now can you see the number of carbon atom in the first part? That is 5. So longest carbon chain is 5. But if you take here, if you take in the second compound, the straight number carbons are 5. Okay, but we have to take maximum number of carbon atom. It should be straight also, and maximum means there should not be any discontinuity. This is the only condition. It's not like that it should be a straight line only. It can be a curved, but there should be continuity. So now if you see go direct, then how many carbons are coming if you go direct? And if you go with some term, then how many carbons are coming? Please write. Please tell in the, you can on the speakerphone and tell. if you are going straight, then how many carbons are there? If you go taken the turn from 3 to 4, 5, 6, how many carbon came? So there was 5 and there was 7. So root carbon should be maximum. Whenever you are doing naming, root carbon should be maximum. This is the rule. Okay. So now second rule is that now you see if now this hydrocarbon, this contains functional group, yes or no? Or which functional group? This contains which functional group? This example in the left hand side contains which functional group? Can you write in the chat box which functional group it contains? It is alcohol. So now if you give numbering from the left hand side means this down, this compound has given left hand side. What is the number given to OH? What is the number given to OH in case of this second compound? Not first top I am talking about, second I am saying. What number is given for OH? It's 4. And in the previous, in that first example, what number is given? OH 2. So we have to do the numbering in such a manner that functional group should get the least number. Functional group should get the least number. This is the priority. Is it clear to everyone that functional group should get the least number? Is clear? Similarly, you can see here, if you are having this hydrocarbon, see here. Now, how many long carbons were there? Straight chain was how much? Tell me, how many carbons are there in the straight chain? Straight chain, how many carbon are there? 6. So, one time we are saying, so we have to take long carbon, root carbon, long chain we have to take. Second point of that is that we cannot leave a functional group. Even though chain can be small, no problem. But you cannot leave functional group. This is a rule next. Now you see, if this was 6 carbon, we have not done naming in that. We have done naming to include the functional group. Functional group you cannot leave. Functional groups are like parents. Functional group like forefathers. You cannot, grandparents, you cannot leave. They are superior. You have to give least number to them. That's one aspect. Second thing is you cannot leave them. Right? Absolutely. Okay. So let us move ahead. Is it clear? The idea is clear to you that functional group cannot be left in the naming. Is it okay? It cannot be made substituent. It cannot be made substituent. Provided the higher authority member is there. Okay. Next. So now you can see if 2 substituents are there. Now Br is also there, Cl is also there. Now first case was there, we can do numbering from left hand side, and second case is there, we can do numbering from right hand side. Why we have not done from right hand side? Why we have done from left only? Can anyone tell? Why we have done numbering from left hand side only? Why not from right hand side? You can speak or you can write in the chat box. Why you have done numbering from left hand side only? Why not right hand side? Can't we put this 1, 2, 3, 4, 5, 6? This also we can do. Why we have done from left hand side? Why not from right hand side? Please write in the chat box if you are knowing. If you are not knowing, then you write no, so that I can continue. Hurry up, hurry up. Okay, so what I say is, because if you do from right hand side, then 1, 2, 3. So chloro position will be 3 and 4, 5. Then bromo position is 5. 3 plus 5, 8. Now in this case, bromine is having second position and chlorine is having fourth. 2 plus 4, 6, which is less. This is known as sum of locant rule. Sum of locant rule. This is one aspect. Second aspect is the bromo and chloro. Which is coming first? B is coming first or C is coming first? Which is coming first? B or C? Alphabetically, B is coming first. So B is coming first, so B should get the least number. This is also one condition is there. When there is sum of locant rules are same, but here already sum of locant rules are not followed, so we have to follow first sum of locant. Next hydrocarbon is that we have to select the longest chain. You see, now if I will select in this way, 1, 2, 3, 4, 5. If you select like that, 1, 2, 3, 4, 5, 6, 7. Now 1, 2, 3, 4, 5, 6, 7. These all the options are there. You can do numbering from here also. Please see. You can numbering from here 1, 2, 3, 4, 5, 6, 7. Then 3 position ethyl. Now also 3 position ethyl only. So it is same. Naming will be same whether you will start from this corner or this corner. Okay. Is it clear? Is it clear? Please write yes or no so that we can take up the next portion. Like 15 minutes are there. So we'll cover up. The branch chains are considered to be substituent. For example, previously there are 5 carbons. 5 carbon hydrocarbon name is what? Why 5 carbon hydrocarbon name? What would be the name of hydrocarbon with 5 carbon? Please tell. Pentane. Okay, pentane. So now if one H is removed and place CH3, if one H is removed and place there CH3, that CH3 is methyl. CH3 is methyl because we written R was alkyl and C1 is there, CH3 to become, if N is equal to 2 it becomes C2H5. So that is methyl or ethyl. Okay, so this is methyl. So now why we have done numbering from the left hand side? Why not from the right hand side? Methyl should get the least number. Methyl should get least number. That's the reason. Okay. Now next part is if you are talking of longest chain. So now longest chain you see left hand side, left hand is this hydrocarbon, 2 position methyl is there, and here 4th position methyl is there, which is this. Of course the methyl should get the least number. Methyl should get the least number, substituent should get the least number, functional group should get the least number, right? So if that long chain is not followed and functional group is followed, then also it's okay. So previously example we have seen that. Is it clear now? So is it clear? Now we will take up the basic nomenclature. So basic nomenclature says that we should know about the prefix, we should know about the root carbon, we should know about the primary suffix and secondary suffix. This part we have made it clear to you. So this was our hydrocarbon. So now can you please tell me that left hand side or right hand side where numbering you will start? You can write in the chat box where you will start the numbering, left or right. CH3, C, CH2, CH3, this side or right hand side? Please tell. What would be? Left or right? It would be left. Why left? Because in left only 2 methyl groups are there and that will get 2 number. And if you start from right hand side it will come 3. That would be wrong. So here 2 dimethyl. If a single carbon is having 2 methyl group, then it is known as dimethyl. Okay. And then the root carbon remains same, that is good, and then suffix is "ane" here. So take the example. So now left hand side or right hand side, from where you should do naming. In example number 1, left or right? Left or right? Naming will be done in left or right. Any, yes. Because 2 is getting the same number. Okay. So now you are very clear that 2 position we are having substituent. Substituent means prefix. Prefix means methyl. So methyl is there 2 position and root carbon how many? 3 carbon. 3 carbon means propane. So this way we can do. Now please remember that naming is one word naming except prefixes. Prefixes and carboxylic acid. So there can be, we can write separately, otherwise one word name. Okay. Now the next question, example number 2 of your book. Now you will do numbering left or right. Please tell. Numbering left or right. Example number 2. Example number 2. Numbering left or right. Any side. Yes. So any side means, so this way now you can see that we can do the naming also. So naming says 2 and 3. 2, 3 dimethyl and butane. Very simple. And first letter is always small. Okay. So next here if you talk of how many substituent are there? 1, 2, 3, 4. 4 substituent. Which substituent are there? Chloro, 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 chloro. So how many, which position is there? 1, 2. 1, 2, 2. Then tetrachloroethane. So this way we can do the name. Write the name. Okay. Very easy. Not that difficult. Now which functional group this is? You need not to see this answer. You have to see this. Which functional group is? I want to ask you. Which functional group it is? This one. 4th example. It's ketone. So how many carbon it possess? How many carbon it possess? How many carbon? 3. 3 means root carbon is what? Propane. And what is the functional group name? On, not one. On we say. Propane plus on. So E and vowel cannot come together. So the name is propanone. So now here they have written propane 2-on. Can my question to you is whether one propanone possible? Whether one propanone is possible? No, one propanol will not be possible. One propanol will become propanol. One propanone will become propanol. Okay, so this is the main point why we should not, why this will not come. If you will not write propane 2-on, then also marks will be given because it cannot be 1, it cannot be 3. Okay, in this particular compound. Now, example number 5. So now here it is alkyne family. So how many carbon it is having? 1, 2, 3, 4. 4 carbon. So 4 carbon is good. Good. And what is the position of ion? It is second position. Second position is good 2 ion. Hyphen. So whenever numerals we are writing, we should prefix and postfix plus that hyphen. That just like for here, good hyphen 1, good hyphen 2 hyphen ym. So this hyphen is required in separating the numerals. Okay. So example 6 also clear to you. You can do numbering left or right. We can get to know. Okay. Let us move to the next part. So now I am not writing the name. I want you to, one of you should speak. Okay, one of you should speak. I have covered the answers. Who will be doing? Who will be doing the answer, writing the answer? Just clear. Okay, go ahead. Example number 7.
3-methyl hexane.
3-methyl hexane. Absolutely right. Okay, next who will be ready? Next who will be ready? Okay, Gitali, tell.
2,3-dimethyl heptane.
2,3-dimethyl heptane. Absolutely right. Very good. Okay, next who will be doing? Next who will do? Everyone should participate. Then only learning will take place. Who else will do? Okay, Gitali, yeah, carry on. Please tell.
3,3-dimethyl hexane.
3,3-dimethyl hexane. Okay, fine. Next who will speak? Carry on. Don't waste time. Just continue.
It is but 2 ion. But 2
ion.
in.
So please always you are clear. Also you are telling in ion. So you have having confusion. Please check it out there. Now what is the naming here? Name here.
3-methyl.
3-methyl. Now my question to you is: can we start numbering from the right hand side? Can we start numbering from the? No. Methyl is on left hand side. Methyl is not a problem. Problem is with the double bond. Double bond should get the least number. Okay. So therefore, now tell the naming.
3-methyl.
Okay.
Pent-2-ene.
And 2 and hyphen 2 hyphen ene. This is okay. Now, which functional group this is? Which functional group? Ketone. Yes. How many carbonate has having?
5.
Pentane and ketone position
2.
So pentane 2-on. So like that is there. So chloro is also there. So chloro we will take. Now numbering should be done from left or right?
Right hand side.
Numbering should be done in. Okay. So let us see. Now do it this one. Numbering should be done from right hand side because functional group in the right hand side. So what would be the name now? Please tell. What would be the name? Two position. What is there?
Methyl and chlorine.
2 chloro. I will increase the size. 2 chloro. Hyphen 2 methyl. Butane. Butane should come. Butane will not come. Butane 1-on. Butane 1-on. Right? E will be not be there. So see here. Butane 1-on. E will not. 14. So 14 C. 14. Please try to do yourself.
2-methyl.
Yeah, 2-methyl propane 1-on.
1-on.
Right? So now whenever you are writing prefix 2-methyl, so then there will be space. Okay, otherwise no space will be there. When you are writing prefix, space will be there. Now what about this last? This one. How to write? Example number 15.
2, ethyl, 4, methyl,
2 comma not 2 hyphen
2 hyphen.
2 hyphen ethyl and comma 4
hash.
methyl hyphen methyl and then further pentane pentane. Then E you will cut pentane 1 right. See 4 ethyl. Okay, we have missed actually. It was down. We could have missed it. There are 2 ethyl 4 dimethyl pentane 1. Okay. Now please tell which functional group this is. 16th. Which functional group? Aldehyde. There are 2 aldehydes, so we say diol. But this type of compounds are not coming normally in the exam. So for 5 carbon, you will say total 5 carbon. That functional group it will be included in the chain. So 5 pentane 1 5 diol. So normally this will not come in the exam. What do I feel? Only one single functional group. Okay. Similarly, pentane 2 on. Is it okay? And the here last is 2 ethyl butanoic acid. If any doubt is there, you can ask. You can ask if any doubt is there. Is it okay?